guys. So today we're going to talk about our sun. In particular, we're going to talk about the layers of the sun. As you can see here, there are several layers, just like we learned about layers of the earth or layers of the atmosphere. Our sun, because it's the only one in our solar system, we know the most about it, so we actually have different layers to learn. Okay, so first we're going to start with the innermost, and this is the core. And we've already kind of talked about this. So the core is where the sun and all stars produce their energy. This is where nuclear fusion takes place. And think back to when we learned about how stars are made. So this would be the most intense part of the sun of any star, again, where the energy is being created. If you go one layer up, then you'll get to the radiation zone. So the radiation zone is defined as the layer where the gas is really tightly packed together, and the energy is going to move at this point like an electromagnetic wave. So think about radiation, those waves kind of going up and out of the core as they radiate in all sides. And that's the radiation zone. But really very, very dense here because everything is so packed together as it's the central part around the core, the central part of the star. So because it's so dense and just jam-packed full of those hydrogen and helium atoms, that it slows down the process of the energy getting from the core outward. And so the book even described that it could sometimes take as long as 100,000 years for energy just to travel through this layer alone. So that's the radiation zone. If you move one outer layer next, that's going to be the convection zone. So the convection zone, this should seem familiar to you. There's that word again, convection. So this is the outermost layer of the sun's interior. So if you could consider the sun to have an actual interior part of it, this would be the outermost part. This is where the heat circulates. There's that convection talk again. Heat rises, cools, sinks. Heat rises and cools, sinks. So at this point now, over here you can see here's the core, radiation zone as it's radiating out from outward, and then the outermost part of the sun, you can see here we have it circulating around, creating that more stable and consistent temperature in the convection. So that's of the sun's interior, innermost parts. So now let's talk about its atmosphere, because we're not done yet. There's more layers to go. The photosphere is next. The photosphere is the inner layer of the sun's atmosphere. So if you could stand on the surface of the sun, the atmosphere that you would be kind of existing in would be the photosphere. And here the gases are thick enough that we can actually see them. So this is the visible layer. Think of photo like a picture. This is the layer that we can actually see. So if you see any pictures of our sun, obviously you don't look directly at it outside, but if you see pictures of it, what you see is the photosphere. Like this picture here on this slide. And going one out from that is called the chromosphere. The chromosphere, this is the middle layer of the atmosphere. And this layer, and then the next one that we're about to get to, is the parts of the sun that we can't see unless it's during a total solar eclipse. So in the process of this solar eclipse, sometimes we'll see this reddish kind of hue, this reddish color glowing around the sun, and this is the chromosphere. A way to remember this is chroma means color. So when we see that pretty red color kind of going all around the sun, so this is clearly during an eclipse where it's being blocked out. The sun is so bright that it kind of washes out these last two layers that we're talking about. So only in eclipse would you be able, your eyes to be able to see the chromosphere. After the chromosphere is the corona. The corona is the outermost layer of the sun's atmosphere, and it extends all the way outward into space. Again, we can't see this unless it's during a total solar eclipse, and this is the one where it's the pretty kind of halo glowing around the sun. Another thing to kind of know, maybe you didn't know this, corona means crown, so it kind of looks like the crown of the sun. That's where its name came from. Okay, so those are the layers of the sun that I hope you've added into your notes. We're going to talk about a couple of important parts of the sun next. The first one are the sunspots. So sunspots we've kind of talked a little bit about before. Sunspots are areas of gas on the sun's surface that are cooler in temperature than the gases that are around them. So they're cooler. They're darker color too, if you obviously from the picture you can see. And the reason they're darker color is because cooler gases will give off less amount of light. So the hotter ones will have more color. Sunspots will vary in a cycle. We go through a pattern of when we see more sunspots and when we see less. And that rotates, that cycle goes every 11 years. And right now, I looked it up, we are probably this year in what we call solar minimum, where we have the fewest number of sunspots that we'll see. Usually we don't see too much action from this affecting us on a global scale, but there's some theories behind that. So maybe there will be more research done. So those are the sunspots. Next are called prominences. A prominence is this loop of gas that links different parts of sunspot regions together. So it's you can see here, this is a loop. So it's like it's branching together these two sections of the sunspot regions on the sun, kind of like a bridge. Because sunspots usually occur in groups. So within themselves, they can kind of hook their energy together and create this prominence. And prominences happen all the time. Hundreds of them happening all at once. And that doesn't normally affect us, but sometimes prominences can make a solar flare. So a solar flare is when that prominence not only connects together, but then they release. So the loop end closes off and kind of pinches out and sends that solar flare out into space. So it disconnects from the sun and ejects out into space. Those can get more harmful because if a solar flare comes to Earth or near us, it can cause problems for our satellites and certainly for the health of our astronauts that are out in space. So NASA's keeping a careful eye on those solar flares because it could be bad for us. You don't want anything to happen to your satellites. What would you do without your phone? Okay, so one more thing to know. It's called solar wind. Solar wind is just a general term for particles that exist from the sun out in space. So solar wind is not really a bad thing. It can get worse during solar flare times, but solar wind is not necessarily a bad thing. Luckily for us, we have our atmosphere and our magnetic field that protects us. It blocks out a lot of this solar wind. As you can see in this picture here, sometimes they can interact with our magnetic shield and it will travel to where our magnetic fields, they loop around and connect at the north and south poles of our planet. So when solar wind is coming and it interacts with that, that magnetic field, it can travel up the magnetic field or travel down the magnetic field to those North Pole, South Pole regions. And when it stops there, it will create a light show. And we can see those pretty lights. These are called the auroras, or you may have heard them referred as the northern lights. Of course, if you are in the southern hemisphere, they're called southern lights. But this is where you see these pretty beautiful light shows in the sky. And those are the auroras. So those are perfectly normal and just another way for Earth to show you that it's protecting you from some harmful stuff. Okay, so that is all that you need to know about our sun. Thanks, guys.